This is the story of how 6-PPD, an industrial chemical that has been used for more than 60 years, suddenly became an important chemical of concern just a few years ago in December 2020. It involves the life cycle of salmon, increasing population problems, the manufacture of tires, and weather effects of global warming. The story begins in the Pacific Northwest in the early 1990s, when university and government biologists noted that salmon returning from the ocean to spawn in upstream freshwater streams were dying before they spawned. More than one half, sometimes all, died with their eggs intact. Why was this happening? Searching for the cause, researchers ruled out high water temperatures, low dissolved oxygen, known pathogens and contaminants as inadequate for the magnitude of the kills. The one clue to the cause was that the fish were always killed after it rained. Something in the stormwater runoff was killing the fish. Researchers linked the fish kills to traffic density. The more traffic in a stormwater drainage, the bigger the kills. But there are thousands of different chemicals in road stormwater runoff. What toxic chemical or combination of chemicals was the problem? Finally, after decades of trying, researchers in December 2020 identified a single, up to then unknown compound, 6-PPDQ, as the toxic compound killing the salmon. As the similarity in their names suggests, 6-PPDQ and 6-PPD are related. The toxic chemical 6-PPDQ is a product of the reaction of ozone, O3, with the tire additive 6-PPD. The compound 6-PPD, now on the EPA Chemical of Concern list, has been used in the manufacture of tires for more than 60 years without problems as an anti-degrading additive to the rubber formula. It helps to slow aging and cracking of tires due to oxidation and especially ozonation. Added as a powder, it is not soluble in the rubber mix, but slowly migrates over time from the interior of the rubber to the tire surface, where it forms a protective film. 6-PPD at the tire surface reacts with atmospheric ozone faster than the ozone can react with the tire, while 6-PPD within the tire rubber serves to replenish the surface protective film over the lifetime of the tire. At present, 6-PPD is the most effective anti-degrading rubber additive available. It is the anti-ozonant of choice globally by the tire industry. While no one can accurately estimate the amount of 6-PPD present in the world today in 2024, an estimated 50 million to 100 million pounds are produced each year as a protective additive to tire rubber. While other rubber products also use 6-PPD, tires are by far the largest global reservoir. It includes all the tires currently on vehicles, tires being produced, stored tires in warehouses, tires in waste piles, and many tires simply abandoned. When the report that first identified 6-ppdq as the toxic chemical killing the salmon was published in the journal Science in 2020, a storm of scientific investigations quickly followed, measuring its effects on other fish and other organisms, including humans, and looking for pathways to control the problem. Much has been learned, but the subject is very complicated. There is still a lot of work to be done. Here are some things we have learned from published reports. First, how does 6-ppdq get into surface waters? Unfortunately, the same properties that make 6-ppd outstanding for improving tire performance and safety also make every tire and every fragment of tire debris a long-lasting source of toxic 6-ppdq. Tire abrasion leaves tire fragments on road surfaces that are mobilized by rain and flooding and carried in the urban stormwater runoff to surface waters in the drainage basin. The reaction of 6-ppd with ozone to make the toxic 6-ppdq is always occurring on every tire fragment, so every tire fragment becomes a source of 6-ppdq. 6-ppdq is soluble enough to dissolve into water in concentrations that are highly lethal to coho salmon. For coho salmon, there are 3 reported values for LC50. This is the concentration that kills 50% of test fish. All are smaller than 0.1 micrograms per liter. Reported values for dissolved 6-ppdq in urban streams in the Seattle area during dry weather were all higher than the LC50, sometimes as high as 19 micrograms per liter. During storm events, concentrations were as high as 30 micrograms per liter. This means that urban streams in the Seattle area were usually acutely toxic to coho salmon. Another important property of 6-ppdq is related to its toxicity to different fish. Even though it is extremely toxic to coho salmon, it is much less toxic to other types of salmon that have been tested. All the fish in this table are in the salmon species. Coho salmon are by far the most sensitive to 6-ppdq, and quite a few of the species tested have low sensitivity. Testing the toxicity of 6-ppdq to other forms of life is an area of active research. Now we come to the WWE part. What is being done about this problem? The EPA has just published an analytical procedure for 6-ppdq and are developing screening values that are protective of sensitive salmon. Tire makers are actively looking for substitutes for the 6-ppd additive, but even when one is found, the testing procedure to make sure it doesn't reduce the useful lifetime and safety of tires and doesn't have any hidden surprises like 6-ppd did will take 5 to 6 years. Also, if a good substitute is found and put into production, it will be a long time before all of the current 6-ppd tires are gone from the environment. This all means that banning the production of 6-ppd now would not have any observable effect for a long time. The most effective way right now for controlling 6-ppdq is to keep storm runoff from crowded highways from reaching critical surface waters. This involves using the methods of green infrastructure, street sweeping, roadside swales that are vegetated and compost amended, and bioretention ponds with a soil mix high in organic content. 6-ppdq sorbs well to organic matter. This is the end of the presentation. There is much more information easily available on the Internet. EPA and the University of Washington have dedicated websites that continually update 6-ppd and 6-ppdq research data and government regulatory activity worldwide. I will try now to answer questions.